Have you ever wondered if time travel is possible in outer space? It's a question that has captivated our minds for centuries, fueled by imaginative works of science fiction and blockbuster movies. In these fantastical narratives, time travel often involves hopping into a futuristic machine, pressing a button, and voila, you're in the past or the future. But the reality of time travel, according to our current understanding of physics, is much more complex and less straightforward. This is where the concept of time dilation comes into play. Think of it as a form of time travel that doesn't require a fancy machine. It's a phenomenon predicted by Einstein's theory of relativity, where time can appear to move slower or faster depending on how fast you're moving or how much gravity you're experiencing. So, while time travel as we see it in movies may still be a work of fiction, time dilation gives us a scientifically plausible route to explore. Now let's delve deeper into the concept of time travel in space. To understand time travel in space, we first need to understand time dilation. Now you might be thinking, time dilation? That sounds like a term straight out of a sci-fi novel. But bear with me, it's not as complicated as it sounds. Time dilation is essentially a difference in the elapsed time as measured by two observers. Imagine two clocks, one on Earth, and one zooming past in a spaceship. According to the theory of relativity, the clock on the spaceship would seem to tick slower than the one on Earth. This is because of the high velocity of the spaceship. Now let's add gravity into the mix. Gravity also affects time. The stronger the gravitational field, the slower time passes. This is why time runs a tad slower for your feet than for your head. But let's scale this up. A clock closer to a massive object like a planet will tick slower than one further away. This brings us to the concept of relative time, a cornerstone of Einstein's theory of relativity. Time is not absolute. It's relative to the observer's state of motion and the strength of the gravitational field the observer is in. So when astronauts orbit Earth at high speeds and in a weaker gravitational field, they age a smidge slower than us folks on Earth. Time dilation, folks. So, in a way, astronauts in space are already time travelers. Time travel isn't as straightforward as it might seem. It comes with its own set of paradoxes. Let's dive into a couple of the most famous ones: the grandfather paradox and the bootstrap paradox. First up, the grandfather paradox, a classic thought experiment that raises questions about the very nature of time and causality. Imagine that you've built a time machine and you travel back to a time before your grandparents met. What would happen if, by some unfortunate accident, you caused your grandfather's untimely demise? If your grandfather passed away before he met your grandmother, your parent would never have been born, and neither would you. But if you were never born, who traveled back in time and caused the accident? Next we have the bootstrap paradox, named after the phrase, pulling yourself up by your bootstraps. This paradox involves an item or piece of information that is sent back in time, creating an infinite loop where no one can say where the item or information originated. Picture a scenario where a scientist receives plans for a time machine from her future self, builds the machine, and then sends the plans back to her past self. Who actually invented the time machine? These paradoxes make the concept of time travel even more intriguing and complex. They challenge our understanding of time, causality, and the universe itself, leaving us with more questions than answers. So, what does all this mean for the possibility of time travel in outer space? Well, our exploration thus far has taken us through the labyrinth of time dilation, where we've seen how time can stretch and squeeze based on speed and gravity. We've looked at the mind-bending paradoxes that could arise if we could jump back and forth in time. A fascinating web of cause and effect that might have us questioning the very nature of reality itself. We've seen that time, like space, is a relative concept, not an absolute one. This understanding pushes us to rethink our concept of time as a linear continuum, and opens up a universe of possibilities, some of which include time travel. While the intricacies of time travel are complex and often challenging to wrap our heads around, they make it a mesmerizing field of study. While we may not be hopping in a time machine anytime soon, the exploration of time and space continues to be a captivating journey.